Hello, hello, hello. Good morning, good evening, wherever you are. Welcome to Kubernetes and Enterprise Guide, third edition labs. We never really gave a name to this. I think we go with a new one
Mm.
every time. And you've got a new friend back there. I noticed him on the
Mm.
call earlier today.
Yeah,
And is that the only one?
yeah, my mom is a big fan. So
Okay.
I 3D printed that. Anybody that watched my post saw that I have a very big 3D
Oh
printer
my
now.
goodness. Well, and I was going to say that's got to be built with that monster that you bought.
It is. It is. It's part of the big printer. Although I would have done this on another printer too. But yeah, my wife was kind of getting tired of him being in the family room while I'm painting him. So I said I better move him. So yeah,
That's a great model. I love that one. So yeah, my name is Mark Borstein, CTO of Tremolo Security. With me, as always, is my co-author Scott Sorovich. Scott, you want to say hello?
hello. No, okay, and just being a kind of like kind of
I teed that one up for you.
Yeah, you did. You did. It was an easy one. I am Scott Strowich. Principal engineer, lead Kubernetes with a tier one global bank.
Cool. So this week we are going to begin the first of 3 weeks, spread over 4, but 3 weeks on the vCluster chapter and talking about multi-tenancy. This chapter was so much fun to write. Like, it was easily one of the most fun I had writing a chapter because it's such an interesting technology. I've been beating the drum of multi-tenancy since 2016, right? Like I love to pull out I'll see if I can find it maybe later in the show. But the first KubeCon that was in Seattle in 2016, we were a sponsor. And this is when KubeCon was small enough that the expo hall was the hey Kafka.
I
Oh,
saw
I'm
it
on
on
the wrong
there.
screen. That's why I didn't see it on
Yeah,
there.
I saw it. Hey, bonjour.
But when KubeCon was small enough that the expo hall was the lobby in the Sheraton in downtown Seattle, and there we were, and I had the Tremolo booth, and I had my stack. I called it my data center in a box, running a multi-tenant Kubernetes cluster with a namespace as a service, and we had Active Directory on one single board. This is no, these were pies. Now that I think about it, these were pies.
Your
These
originals
were
were done. Okay,
pies. Yep. And I was using Open LDAP as a stand-in for Active Directory. And then we had a 3 or 4 node Pi cluster. These must have been Pi Bs.
probably
Those
3
had what?
Bs at the time.
2 gig of RAM,
I
maybe
think.
4, maybe. And what was really fun about those was not to go too far off track, because we never get distracted on these streams, is that at the time OpenJDK did not support floating point hardware based floating point math on ARM. So starting up OpenUnison on a Pi with OpenJDK took like 20-30 minutes. And then I switched over to Oracle JDK, and it started up in like 45 seconds. But so I've always been a big fan of Kubernetes multi-tenancy long before it was cool. And Scott, you've always been a big fan of multi-tenancy in Kubernetes as well.
Yeah, from day one, we were big partners with Google Anthos before it was Anthos, and I remember my first Google Next when the product was just not even being announced, but discussed because it wasn't out yet. And I think even at that point we had 165 namespaces in our cluster, which when I presented that to the audience afterwards, people coming up, oh, why would you do that and not create 10,000 clusters? And I'm like, yeah, ever try to manage all those? So there's always good reasons to maybe not go multi-tenant, but rare cases. But yeah. I mean, I come from virtualization, right? For many years. So multi-tenant always made sense to me. And even in the old days, people tried to segment virtualization. right? They'd say, let's make a tier 0 cluster. Let's make a cluster just for sales, just for the trading platform. And we started that way, kind of like Kubernetes, right? A lot of people Kubernetes as a service. And people started to say, what a waste of hardware or utilization. No matter how you look at this, you're doing n plus 1. You're spinning up 1,000 different clusters. That's 1,000 plus ones just so you have a tier.
Yeah.
You don't need that if you're making fewer, bigger clusters. And of course, people on, watching might think, what is that bigger cluster? Well, that's a relative term, right? I don't go thousands, but we, go into the hundreds of nodes. Got to worry about that blast radius. But yeah, absolutely. I was always strongly opinionated on it. And we've been doing it for a long time now.
Yeah. And I mean, I think one of the things that I've always found interesting about watching the Kubernetes market and watching the way people talk about multi-tenancy is the popularity of multi-tenancy seems to have increased with the idea that maybe we shouldn't be spending tons of money on resources, right? Like when everything was basically free, nobody cared. But once you had to start paying for things, because remember in the beginning, like when you launched a GKE instance, you didn't pay for the control plane nodes until you did, right? Like it wasn't until I think 2017 they started charging for control plane nodes. EKS originally you didn't pay, you paid for your EC2 instances, but you didn't pay for EKS. That took them a little while to start charging for it. Like in all the other clouds is the same thing. And then density, right? Like, if every app team gets their own cluster and you've got, all those nodes that just aren't doing anything most of the time, you're just burning dinosaurs, right? You're hurting the environment, you're hurting your wallet. Like pick which one is more important to you. They both happen.
You got a key point in there though. Market people don't think about it is licensing. Right now, I know we all know people. It's come from an enterprise. You're probably not open source for every cluster with every tool, right? That's just, first of all, it's against regulatory in certain countries where you got to have some kind of escalation and support. But I like to bring up WAF as an example, right? So some web application firewalls where you get them from say a 5. You need at least 3 in your cluster, right? For high availability.
Yep.
Well, if I got 100 node cluster, that's still just 3 or 4 I'm doing. However, if I break that down into 20 smaller clusters, now I'm buying 60 licenses. So like you said, when it's all open source and free, yeah, you got compute resources you're going to waste. But you see that less than, oh, wow, I got a yearly license fee for whatever add-ons you might have.
Yeah, that's a great point. And then the final cost that we hadn't touched on yet is the people cost, right? If every application team has its own cluster, it means every application team probably needs to have its own Kubernetes experts.
More than
I think
one.
it's expensive.
Yep. Well, it's easy to find people, Mark. We know that.
Well, yeah, exactly.
Really. So yeah.
So it's one of those things that multi-tenancy, especially in the last couple of years, has really exploded. And I first came across the vCluster project from Loft at KubeCon 2021 in LA, where Lucas, their CEO, did this great this great session and brought up the fact that the official documentation for Kubernetes called a namespace a virtual cluster. And it was wrong. He's like, and I keep bringing this up and nobody wants to fix it. I think he ended up offering some kind of a fun prize or something to fix it. And eventually got fixed. And I want to give a shout out to I hope I say this right, Shabir. I hope I'm saying that right, Shabir. If I'm not, I apologize. But this is a great use case for ephemeral environments, and we'll talk about that as a use case.
But we'll go beyond that, right? Ephemeral is an easy one to kind of look at to say,
Oh
cool,
yeah.
let me do this. But there are some, especially in multi-tenant, right? I
Yep.
know we'll talk about that, Mark, because I think even before you saw them at KubeCon, we talked about it a little bit because my headaches that I've had with
Yep.
some of
Yep.
this multi-tenant and cluster resources. And I know we just kind of dabbled in it back then, and then
Yeah.
sort of just really look at it, right?
Yeah.
Automation and everything else that we created.
Yeah. And it's interesting when we first conceived of this chapter when we were talking to Packet, um, it wasn't solely focused on the vCluster project. The idea was we were going to talk about some of the other, like, always planning on using it as the tech demos, but we wanted to talk about, there were a couple of other, like there was a SIG at one point, and want to give a shout out to Alan. Always happy to
Hey,
come on in. I hope we're making your commute a little more pleasant. And I can't see who your avatar is. Is that you, Alan, playing baseball? I can't really tell. But want to give a shout out there. So there was a SIG. I think Alibaba was trying to do something in this space,
there's been a couple,
and
although a lot of them have mentioned the ideas, Mark, like a V, but not as extensive, right?
yeah, and vCluster just won, right? Like those technologies, those projects have either shut down or they're not, um, they never came to fruition. Whereas vCluster has really gotten some nice industry momentum. And so instead of talking about virtual clusters, this chapter became about vCluster, which fine by me because I love vCluster. It's a great project. So one of the things that we did with this chapter, the last few chapters we were running long, like really trying to. Okay, well that now you're just showing off, Alan. Sorry.
Yeah, I see. I only
But
run if
no,
I'm being chased.
congratulations, man. That is awesome.
I'm only running if I get chased by zombies. So let's
Yeah.
give a lot of credit.
Isn't it from wasn't that one of the rules of zombie apocalypse? Cardio, that's important.
That's Zombie Land. Yeah, cardio and yeah. Well, always remember, you always got to be fast. Or there's a shirt that
You gotta
says
be
"I
faster
like
than the
you."
other guy. You don't have to be
We do.
faster than the zombies. You just gotta be faster than the other guy.
The one shirt I want
Um,
says "I like you," but if we're chased by zombies, I'm going to trip you.
yeah, that's
Right.
fair. I
So
understand that. So we've been running long on these chapters because we end up having about 20 to 30 minutes talking about it. And then we dive into the labs, and the labs have been running 30 to 40 minutes. So there's a lot going on in this chapter. So we're going to break it up into three videos, three live streams. So this one is going to be our introduction. We're going to talk about what vCluster is, how it works, and start diving into um, uh, uh, start diving into how vCluster works, how to deploy it, how to set it up, and then we're going to talk about enterprise authentication into vClusters and how we treat that. Next week, or actually 2 weeks, because I'm on vacation next week, we are going to dive into security. So we're going to talk about how vCluster handles its own identities for pods and how you can use that to talk to an external service, in this case Vault. So like last week we did Vault. This week we're gonna leverage what we learned to get our 2 weeks we're gonna leverage what we learned, and then the final week we're going to dive into automation because it's Kubernetes. You shouldn't be manually running commands. So we've got a fun filled month here, and then want to say thank you very much again to Shabir. Thank you for helping. Thank you for letting us know of our contribution. So
and
thank you
great
so
to
much.
see some of that handing back to the community. Right.
Yeah, exactly. Um, so we should probably talk about what a vCluster really is, right? Like that's probably a good idea.
I'll probably start explaining it right away, Mark, with my
Yeah.
analogy of Russian nesting dolls, because if anybody on the watching has ever been confused just on context in a cluster,
See, I'll
make
actually
sure
take
that
issue with that. It's not Russian nesting dolls, though. It
um,
it isn't, because so here and we kind of, I know I had this as kind of a mental block when I first started, when we first started looking at these for what y'all were working on, Scott. Um, the virtual cluster doesn't run pods,
right.
so I wouldn't call it the
Well, your
nesting
APIs
dolls.
are nested, right?
Your API server runs as a pod or set of
Mm-hmm.
pods,
Mm-hmm.
but and this is the beautiful thing about vCluster, and this is what makes vCluster, I think, really unique, and why it was so successful and has been so successful and will continue to be successful. The trick is, when you launch a pod inside of your virtual cluster, it's syncing that pod definition
Mm-hmm.
into the parent cluster. So it's not really
Right.
Russian nesting dolls so much as it's a
I'll
synchronization.
okay. I'll disagree on
It's
one
not
other
like a
part.
network encapsulation, right? Like
No, no,
there's
no, it's not. But it's similar to the kind cluster in a way too, Mark, because it's well. First of all, you can say that with a pod, right? Sure, you can do a get pods though on either side, see them. However, your CRD that will not show on the
true,
host. So you are
true,
now you get a person that's newer to vCluster. They're going get CRD access denied. What are you talking about? Well, it's because you got admin in the vCluster. I'm going
right?
to say that's where I say it gets. I'm not going to say it's confusing. It is when you start. Just that. Oh, okay, great. Yeah, it's you got to treat it like it's a separate cluster. You really do,
Yeah,
right? I mean, at
yeah,
least from that standpoint. Right, right. Now the pod's running on the host itself. That's a great thing for security, and we'll talk
yep.
about that stuff. So yeah, sorry, didn't mean to jump in too much, but I know from real world experience how this can get some people to start, and the light kind of turns on after you do it a couple times. Say, oh,
Yeah, and I think one of the things that you hit on here is, that there's really two use cases for virtual clusters. Um, the first use case is that ephemeral use case that Shabir mentioned for development, where you can quickly spin up a virtual cluster, test something out, shut it down, right? And that's great for things like automated testing, development. Like, you're just going to spin something up, get it to work, and it goes away, right? It's not a persistent cluster. And we don't really spend a lot of time on that use case, but it's a great use case, right? Because you want to be in a situation where, as a developer, you know, you want to write some code and you want to get it running. It's so much nicer of a feedback loop when you own the virtual cluster and you can break things, and like it just doesn't matter, versus when you have to commit to a pipeline and then wait for that pipeline to run, and then um and
yeah,
then
and vCluster added some of those new features as well as Shabir's kind of calling out is
yeah,
they got the auto power down and that too. So Loft's had those features pretty recently to make that automated. Um,
yeah. And so there's a lot of value there, and that's a great use case, and I love it for that. Excuse me. The other use case, and this is the one where we spend most of our time in the book on, is as a tenant for your production systems, right? Like your you know multi-tenancy prior to vCluster was primarily, you're talking about namespace as a service, which is great. It has its limitations, but it's a starting point. Um, but the nice thing about vCluster is that you get your own API server, which means CRDs, and that's like one of the big ones, right, Scott? I mean, you've got a lot of experience having to deal with CRDs in multi-tenant situations.
we do, we do. We have probably about 20 different types of operators that we've had to deploy across parts of the estate. Well, it kind of makes sense, right? You got Redis, people might want Prometheus, people might want Kafka. There's just so many examples. And the problem is, yeah, as a platform owner and operating team, we don't want to have to maintain those.
Right.
Yeah, every upgrade, you got to worry about these.
Yep.
And of course, there's the other problem. You're running a version of Kafka. How many operators can you run on that one cluster? And how many CRDs? You're limited, right? You can't
Yeah,
run 12 different versions. And in a multi-tenant, you're probably going to hit people that say, oh, I can't run Redis 7.4. I need 7.1. Oh, well, sorry, for doing an operator at a cluster level, you're kind of stuck. We try to avoid
exactly.
that. But yeah, and that's where, at a very easy win, that's where vCluster truly comes in.
Yeah, and so the other nice thing about giving somebody a vCluster, and uh, I did a live stream with our friends at Loft on this. Oh God, probably about a year and a half ago. Um, you can kind of split the baby here, and it can be an ephemeral cluster, but still production, right? Because of GitOps, right? And so you can externalize all your config in Git if the cluster has a problem. Like this is one of the original things that we had conceived of around ephemeral clusters is, central Kubernetes team's time is limited. If you have a cluster that is acting up, and you're having problems, time box the amount of time that you're spending debugging it. And if you just can't fix it,
Blow it away.
big bada boom, get rid of it, redeploy it, resync it in. So, and that kind of brings us to different deployment models that we've got to talk through and what those implications are. But it's a really elegant solution to multi-tenancy, because now you've got everybody gets their own API server, which means that you can give cluster admin access, right, to that API server for your tenant, deploy all the CRDs they want, break everything they want. But the thing is that's theirs. That's their space. They cannot impact the other tenants, even with that level of access, because vCluster runs inside of a namespace. So if that namespace has a resource quota, guess what? You're still bound by it. You're still bound by all the policies of your tenant cluster, or your host cluster, excuse me. So there's just you're getting your cake, and you get to eat it too. Which, like, who doesn't want to eat the cake? Everybody wants to get that. What's the point of ordering cake if you can't eat it? So let's talk a little bit about how vCluster works before we dive into the lab. And so, looking for one of the diagrams here in the chapter. I guess we'll start here. So the way that vCluster works is, let me bring this down here. Too many monitors. All right, here we go. So let me go ahead and share this. So this is from the book. And the way that the vCluster works is, inside of your namespace, you have the vCluster pods. And the vCluster pod has two things in it. It's got a syncer, which we'll talk about in a second. And it's got whatever you want your API server to be. Now, you also need to have a database of some kind. If you're running Kubernetes, 99% of the time, what you're talking about is etcd. vCluster, maybe not so much, right? Because you can be running K3s, you can be running Mirantis's K0s. I think those are the other two besides vanilla Kates, where both of those can use databases. And so I like K3s personally. And the reason I like it is that while it doesn't give you the straight up line speed and transaction speed that vanilla Kubernetes will give you, it lets you centralize your database, which makes management at scale much easier. Now you only have one thing to back up, one thing to manage, one thing to automate. So when you create a pod inside of your vCluster, what actually happens is the syncer gets that and then goes ahead and creates that pod definition in the parent cluster. And we'll see that once we dive into the lab. So when you create a pod in your vCluster is not running the pod. Your vCluster is synchronizing the pod into the host cluster with a bunch of metadata information and overriding its DNS and all these other things. So that's how you're able to virtually interact with your virtual API server, but your pod is still running on your host cluster. So all of the things that constrain any pod in that namespace are going to constrain your pods. So let's start having some fun, shall we? If I can figure out where I get really disoriented because I've got the screen up here and I've got my lab set up down here. So all right, so we're going to start over here. Let's go back here, kube control, get node. Okay, cool. So I have, let's come here to the book. So we're going to start off. I'm on page 277, deploying vClusters. Now I have already set up a clean kind cluster to start over. So you don't have to watch that go. So I'm going to go ahead and do export PS1, get this again, clear. Okay, so we're going to go into Kubernetes, and then we're on chapter 9. So we're going to deploy the vCluster CLI. So now I have a vCluster CLI cluster version, I think. Yeah. So I got 0.24.1. So that's our latest. So the next thing we're going to do is we're going to create our namespace. We're going to keep our tenant. Right? Nothing crazy so far. And then we're going to create our vCluster. Now, this is a laborious process, requires lots of planning, takes hours upon hours to, there we go. So the fun thing about the vCluster create command is that's really just Helm in a trench coat, right? Like it's adding some automation on top of Helm. You can deploy a vCluster with just the help command. And in fact, for Open Unison, we use vCluster pretty extensively for testing in our QA lab, and we deploy it using Argo. So we use Argo CD to deploy the Helm chart for vCluster. It works beautifully. So what's happening now is that a stateful set is being fired up for K3s. Excuse me. The reason why it's a stateful set is because you need a place to store data, and K3s by default is going to use SQLite. So obviously this is not a production viable approach. But we got that set up, and you now see that starting the background proxy container. So when you do a vCluster connect to your vCluster, and we'll talk about some of the drawbacks of this. What it's actually doing is it's setting up a port forward to the API server locally. So I'm now in my vCluster. So if I do kube control get nodes, you'll notice that my control plane is no longer listed, only the worker. Right? So nodes come up just in time into your vCluster. And because we don't have anything deployed to our control plane, it doesn't come in to the vCluster control plane. So let's take a real quick look at our kube config. And you're going to notice that we have two configs. First is kind cluster 01, and that there's nothing crazy there. But then we have the vCluster. And so we have a certificate, right? A master certificate, similar to we do with kind. And we're actually just port forwarding to, let's see if I can find it. There's the context. Trying to see if I can find the That's the client data. I'm looking for the URL. Maybe it's at the top. Here we go. So you can see here, server is 127.0.0.1.0.0.48. So you're now port forwarding into the API server. That's how you're accessing it. So let's go ahead. I'm running through here. So I'm at the bottom of page 277, and we're going to go ahead and do a disconnect so we can get back into our parent cluster. You'll see, hey, look, there's our control plane. And let's take a look at the pods in tenant 1. So we have 2 pods. We have our vCluster running a pod or one container, and we have core DNS. And so whenever you have problems, first place to look is going to be that joke does not get old because it's usually true. But your vCluster here, this is the important one, where this is your pod that's running both your API server, K3s in this instance, and your syncer. So we're going to go ahead and also look at the services. No, I'm over here. There we go. So, we've got a few services here. It's a stateful set, and that includes our headless service that Scott did a great overview of back in the networking chapter. But these are all inside of our tenant or our host cluster, right? You can't access this from the outside world. That's why when you do vCluster Connect, it sets up that proxy container. So that way it can actually port forward into the service. That's not a really great way to access these. And we'll dive into that here at the end. So let's actually deploy something into our vCluster. So we're going to first have to connect. Now, I don't have crew installed on here. I don't think I do. Kube control crew. I do not. I will say the CTX sub kube control plugin. Great plugin for figuring out where you're talking to. So we're now connected to our vCluster, and we're going to create a pod through our vCluster. Where am I? Chapter 9. Simple. Try that again. And now let's take a look at the logs. So the logs are just spitting out the environment variables. If you look here, our Kubernetes service host is 1096.201.216. That's a cluster IP. I'm going to exit out of this. I'm going to SSH back in. I'm going to do a vCluster disconnect. Kube control get service and tenant 1. So our cluster IP for our virtual cluster here was 1096.206.216. See, is that going to be the same one? Yep. So that host 1096.206.216 lines up with our vCluster. So the pod is running in our host, but its environment has been overwritten to tell it, hey, go look at the API server running in this pod instead. It's also updated DNS to go look at the vCluster core DNS server instead of having to go to your host cluster's API DNS server. And so as far as your pod is concerned, you're running in the vCluster, even though you're actually from an execution standpoint, from a process standpoint, you're running in the host cluster. You're just a pod inside of the host cluster. And if you're starting to feel a little trippy, buckle up. We're just getting started. And so we are now going to take let's look at the pods in tenant 1. Now we're already disconnected, and we can see that our virtual pod has the namespace and the vCluster attached to it, because you can actually run multiple vClusters in the same namespace. So that's how vCluster keeps your pod from overstepping each other, is through naming. And then if we want to go ahead and look at, let's go ahead and do a kube control get pod tenant 1 YAML into less, and we're gonna get into here, see if any of the security folks on the line just saw something important. But you'll see that we're overriding all of the environment variables. So these are environment variables that would usually get injected by the kubelet. We're overriding these inside of our pod definition to make sure, or excuse me, vCluster is overriding these to make sure that the pod knows when it makes API calls to its API server, it's going to the vCluster. It's not going to the host cluster. Now that said, if you know that your pod is running in a vCluster and you want to go talk to the parent API server, you can still do that, assuming you've got network network policies that allow it. There's nothing that stops you from doing it. It's just the pod wouldn't know to unless you hard coded it to. And then let's also look down here. Again, along the same lines, we come down to host aliases. We can see the DNS config points to our DNS server, our core DNS. It doesn't point to the clusters. And then we've got our host aliases hard coded. So that's the basics of how a vCluster works. Now we're just talking about pods here, but there are other objects in Kubernetes, right? There are secrets, there are ingresses, there are services. And so what you need to do when you launch a vCluster is figure out what things need to be synchronized from your virtual cluster into your host cluster. So as an example, ingress, right? You could set up a load balancer service inside of your vCluster and then run run off of that. That's doable, right? You would sync the service. Well, how does that work? You'd probably sync the service into the host cluster. The host cluster would launch the load balancer IPs, and then you could attach an ingress that way. So there are different ways you could do that. The easiest way to get into your vCluster, though, is just synchronize ingress objects. So we'll get into that one in a moment. And then the question is, how do you access these clusters? So if we're going with the development cluster, right, that short-lived ephemeral cluster, vCluster connect, right? Like, don't make your life hard. But Scott, would that be a valid way to access these clusters in a highly regulated environment? Oh, you're on mute, buddy.
Yeah, I had that great answer. I forgot it now.
Yeah.
But, any environment, to be honest, Mark, right? I mean, even if it's so people think dev. What if somebody happened to be in dev and did that and broke out, right? I mean, people often think, oh, I don't have to worry about that. It's dev. Once you can, if anything were compromised and you can start, traversing the network, you're going to want to know where that started forensically,
Yep.
right? So, yeah. I mean, I'd say it's good for a home lab. Myself, though, or maybe a demo lab that you've got firewalled, right? If you're in an office, just in case. But yeah, you definitely shouldn't do it that way, right?
Yeah.
But we got to integrate something to do this, right? Mark, I'm not
Yeah,
throwing
it's
you up
crazy how
here, and
that's going to work, right? Yeah, yeah.
and but
Um,
hopefully it won't be too difficult.
yeah. We got 20 minutes, so hopefully it's easy. So we spent a lot of time in chapter 6 talking about the right way to authenticate to Kubernetes. And in the Kubernetes world, uh, that does not mean a certificate, right? And we covered that one in chapter 6. And so go check out the playlist. If you haven't watched it, go back, watch chapter 6. So now the question becomes, how do we do this for our vClusters? There's some different approaches. The approach we're going to take here is kind of the maximum flexibility approach. So real quick here, Alan just asked, have you seen production adoption for vCluster or adoption of vCluster for the CRD use case? I think that answer is yes.
I was going to say that's primarily why I even started reviewing it. Alan, was the management of that. You can manage CRDs in a multi-tenant. CRDs by themselves, right, are pretty benign, but the operators, you got to worry about the cluster roles, and there are too many operators out there that require cluster level operator, right? I have a standard with vendors. First thing I'm going to ask them is, can I namespace your operator? And I'm so amazed at some of the answers I get. Yes, it installs in a namespace. But that's not what I'm asking. I know it can install in a
Yeah.
namespace, but I need it to be scoped. It's going to watch just the objects in that namespace. And a lot of them do this. Redis does this, which they didn't originally. Had a big conversation with them. It is becoming quite a common thing, to be honest, because a lot of enterprises are saying that. Now, even with being able to namespace it, I still like vCluster, right? Because again, cluster operators have to maintain that CRD. And a lot of these companies link it to a version. Now, the CRD may not update, but they update their product to 1.7. Well, they changed the CRD to have 1.7 in it, and it actually looks for that, like Helm would look for an object. And so I've got to upgrade these CRDs, even if they don't have to be upgraded. There's a lot of maintenance to that, right? You're making snowflakes out of your clusters, and that gets tough at scale. So to me, that is my number one use case, actually, Alan. Every other use case is good, right? But my team has to run this kind of stuff, my SREs, and I do not like making anybody's life hectic. I'd use other words, but hectic's all I can say on a public broadcast. But let's not make it too difficult for them, because they'll be cursing my name at 2 a.m.
Right,
Making a
right.
phone call. So
And so while Scott was talking, I had to destroy the vCluster and restart it. This is not the same that's in the book. However, there is a bug in the latest version of vCluster, which did get confirmed, so it wasn't my imagination, that can't upgrade a K3's cluster, that it bombs out. So we're just going to short circuit that and redeploy the vCluster. But again, you can see it's up and running in like a minute. So no big deal. So what we've done here is we've launched a vCluster. And then the next thing we're going to do is we're going to deploy Open Unison. So this is very similar to what we did in chapter 6. I'm going to go ahead and disconnect. And then we're going to basically run the same thing we did in chapter 6, authentication, where we're going to set up our Active Directory in our host cluster, deploy Open Unison to authenticate against it. We're actually setting up Cert Manager here. I don't think we did that in chapter 6. Makes it a lot easier when you're getting into the when you're getting into these cross cluster configurations, just to have a Cert Manager. It'll also become important when we get to multi-tenancy, because we're going to use a MySQL instance as our database. And then we're going to authenticate to that MySQL instance via certificates. And we need a quick way to deploy certificates. So we're going to use Cert Manager. So this is going to take a minute to get everything rolled. I don't know if it's just me. I'm finding that I know Docker Hub has put in some more throttling. I find stuff from Docker Hub is just getting really slow. Anything involved with Docker Hub, the polling is just taking forever.
Yeah.
Maybe we can figure
I've
out a
noticed the
way.
same, Mark, other than
Yeah.
we could cache things. And I've debated for the book of setting up a registry, container that
I
has
don't
all
even
the
think we
instances
need to. Like, I think we can change. We should be. I think we can change the default so that it's not Docker Hub anymore, and maybe it goes to like the either GitHub or Amazon. Like there are
we
several proxy pull
could.
throughs.
Yeah. Yeah, true enough.
Yeah, and Shabir, makes the yeah can do the pull through cache with JFrog. You do
This
it.
requires putting up a registry like Harbor can do
Yeah,
this too, right? So we
Harbor does
could
it.
do something like that, but we're trying to make it easier on readers. Obviously, in a
Yeah,
production environment, absolutely, sure, you would do something like that, and we do that. We even do that for our internal registries. So we've got Nexus running in most regions, pretty popular, but I cache front ends with those with Harbor just to have the even better redundancy.
right.
Plus I'm not pulling. My harbors are very close to my clusters too, so we love to cache it for that.
Yeah, and it's enterprise. Like everybody likes to talk about the small container. Oh, my containers, 5K single binary, like, and that's great when you can do it. But enterprise world, if you can get away with less than 500 megs, you're doing a good job.
Yeah, there's some pretty big containers.
And what's the largest container you've
The one
seen?
that I've hit,
Without
oh
without shaming, without shaming.
no,
We
I
won't
wouldn't
shame.
shame. I wouldn't shame. And the vendor we worked with them, it was 27 gigs at one time.
Oh, that's
Yeah,
that's a container.
they shrunk it to 18.
Okay, well,
We're still working with that. It's actually not a secret container, actually, right? This is it's an IDE environment, so
right.
it's got a lot of components, right? Now, I told them what we should do is make a kind of a multi PVC, which would take care of 90% of that. It's such a big container; they have to stage one every time one starts up because you don't want to wait
Yeah,
for that, right? So
right.
people would go get coffee, come back, and be like, "What the heck? Nothing's here yet."
Yeah, we're waiting here. I'm actually gonna SSH and just to make sure that
Oh, live demos.
that live demos. Make this bigger. My poor eyes. Let's see. Are we still? We're still on Apache DS. Kube control. Get pods and Active Directory. All right, so it's running at least. Oh, it had to restart. Ooh. Kube control logs F. Active Directory. Oh, that's interesting. What did Apache DF have a problem launching? LDAP syntax checker. Let's see here. Kube control, delete pods, all, and Active Directory force. All right. Let's see here.
As you're doing that, Mark, Kafka just kind of mentions, uses Podman instead of Docker. Pretty common. I'm going to say tool that we see, obviously,
There we go.
and Quay. Quay is always a popular place for registries. So agreed on that, Kafka.
So I think we cleared that up. Now we're just, I think, waiting for everything to stabilize. Yep. All right. So this should now. Here we go. All right. So we've deployed Active Directory, and now we're going to go ahead and roll out OpenUS. And this is all still on our host plane. Shabir is asking a question here.
Yeah, I was going to put
I've
that one up.
never. Have you?
No, we looked at something like that, and I got to be honest, the reason we went with something like a Harbor, for an example, was enterprise environment. right? I need to have some kind of support. And of course, Harbor's by VMware. And, regardless to, let's not talk about any Broadcom or anything like that, enterprises still have a ton of VMware, right? So we
Yep.
had some licensing for it. I did look at that one though, Shabir. I didn't get too far into it, but it's a good alternative. For home labs, it's really can come in handy without a doubt.
All right. So we're waiting on. See here, kube control, get pods, and open unison. So, okay, so the test pod is run. Okay, cool. So this is just for some reason my I think I can. My VM is getting a little tripped up here, but we got 2 open unison pods. Now, one thing I have noticed is okay, so we're creating. Yeah, you can see how slow my VM is running for some reason. So the pods are firing up here, and we're downloading. Kind is running as fast as it can. Although, to be fair, this one's not a. I can't blame Docker Hub on this one because we do publish images to Docker Hub still for legacy, but all of our images now are sourced from GitHub registry instead. So we got 1 pod running, so that'll wait for our second pod to terminate. We're almost there. You can do it. Yeah, so we can see it's terminating. Java, why won't you die? Here we go. All right, so Open Unison's deployed. We're going to go ahead and run the Helm charts to actually get all up and running and make it useful. And we're just waiting for the background HTML pod to get up and running, and then we can log into Open Unison. There we go. So Open Unison's been deployed. And so if you did chapter 6, it should all look pretty familiar to you. Go ahead, log in. I'm going to make this a little bit bigger. Same username as and password as in the past chapter. So a little bit different in that we now have this tree up here, and we've got our host cluster now. That's because we're going to integrate our vCluster. And, we can get our tokens, and we're doing all this via impersonation. So we can access everything. We can access everything from away from our VM. So now we're going to do the fun part. So we've run our Open Unison deployment for the host. Now the next thing we're going to do is run a Open Unison deployment on our vCluster. And so what that's going to do is we're going to treat our vCluster as a standalone cluster, which means that our vCluster has to authenticate to something. In this case, it's going to be our parent Open Unison. I'm just going to kick that off because we know it's going to take a hot minute. And okay, so I'm in here. So I'm going to go ahead and run deploy Open Unison vCluster. So while that's running, the reason why we are using Open Unison in both our host cluster and our vCluster. So in this scenario, we're talking Active Directory, but this is true whether you're talking Active Directory, Entra, Okta, whatever, is you're going to have some kind of secret that you need to use to talk to your centralized enterprise identity provider. You don't want that secret on each individual vCluster, because your vCluster has your users have cluster admin access to that vCluster, which means they can get their hands on that secret. The other reason for this, doing it this way, is the people who own Active Directory or Entra or Okta or whatever your identity provider is are not generally the same people that own Active Directory or that own Kubernetes. So you don't want to have to go talk to them every time you onboard a new cluster, right? Like that's siloing. That's how enterprises work. And so what ends up happening is you run into these situations where you're, you don't want to be limited by an outside team. So by connecting a satellite Open Unison to your host Open Unison, you're now centralizing that enterprise authentication, but being able to provide it into your vCluster. The other nice side effect of doing it this way is that by, and I'm just going to check over here because I've run into this before on get nodes, kube control, get nodes, kube control, get pods, and Open Unison, K logs. I'm willing to bet one of these is rate limiting. Oops, kube control. Yep. All right. Kube control, delete pods, and Open Unison L app get Open Unison orchestra and Open Unison. Oh, I did that already. So this is something I'm running into a lot is the rate limiting, the API server rate limiting, because Open Unison is a operator that runs multiple watches. Sometimes when the initial pod launches, the API server is rate limiting it. So got to add something there. But let's see if, so we've got one ready pod. So now we've got to just wait for everything to delete. Got two ready pods. See, will we get there before the, I think it's 200. So anyway, by running an Open Unison inside of the virtual cluster, now your tenant can set up SSO to whatever apps they run in their virtual cluster without having to worry about getting the centralized team involved. So you can actually add, if you want to add Grafana or whatever into your tenant cluster, you can now have enterprise SSO with that without having to get the central team involved. So we've deployed our vCluster. So now I'm going to come back here and I'm going to log out and log back in. So all of our mappings work. And it helps if I remember the password. So now we have this tenant one, right? We have a host cluster and we have a tenant one. And our tenant has its own dashboard. Right now, the only thing in here that's kind of interesting is Open Unison, but you'll notice that we have a lot fewer namespaces than we did with our host cluster dashboard. And then see here. If I don't use Open Unison, well, I need to configure the host kube API server and the vCluster API server with its own authn settings. Yes. Yeah. And you do have to do that with Open Unison too. The only reason why we don't have to do that here is we're using impersonation. So you can configure K3s, K0s, or vanilla K8s with vCluster to use standard OIDC integration. And you can configure that in your Helm chart for vCluster. I like to use impersonation for vClusters just because it's a lot easier to configure. You don't have to worry about certificates, etc. But yeah, that's you need to do that regardless.
Yep.
It's just here we're using impersonation, which makes life a little bit easier. And then have you provisioned Samba server as your domain controller for Kate's authentication? Sort of. Samba doesn't do authentication. It just piggybacks off of Kerberos. And so you can tell Open Unison to trust a Kerberos ticket. But at the end of the day, you're still doing OpenID Connect into your API server. So coming back to
exercises, we're using the Apache DS.
Yeah.
So,
but if we had like a free IPA as an example that uses Samba, that would have a Kerberos implementation. So we would set up Open Unison to trust that Kerberos implementation and authenticate that way. So that said, we've got both of our dashboards, and then if we go here, I'm going to go ahead and snag a token, and I'm going to figure out where is my terminal. So I'm actually local right now. Make this bigger. So just as in chapter 6, we were able to do this. Kubeconfig gets, right? So we get our token, kubecontrol get CTX, or kubecontrol CTX here. So we're in the tenant 1 tenant. Kubecontrol get node. So we're only going to see the 1. Kubecontrol get pods all. So now I have a kubecontrol. No different than my host cluster, right? So as a user, I'm able to log in to my central authentication system, grab the cluster I need access to, and start accessing it. No different than anything else. And so that gives you that level of that secure access to your vCluster that you would want in really any environment, not just enterprise. But yeah, you don't want to, just because you have the ability to treat a vCluster as the small, lightweight thing, which is awesome. From an enterprise standpoint, you totally want to make sure that that your users are accessing it the same way that you would a host cluster. So we covered a lot. I was trying to keep this at about an hour. We did a lot of manual steps. And so by the end of this chapter, we want to stop doing these manual steps, right? That's really what our goal is. So next time we're going to talk about, and so this will be in 2 weeks, we're going to talk about the workload identity inside of your virtual cluster and what that means, and how we could use that virtual identity or that identity to access an external service like Vault. And then we're also going to talk about high availability and upgrades.
Very cool.
So yeah, so thank you everybody for coming to say hello. Want to give special shout outs to Kafka, Alan, and Shabir for coming by and saying hi and hanging out with us and talking. And we're going to be off next week, but 2 weeks, same bat time, same bat channel, high availability and workload identity and upgrades of vCluster. In the meantime, if you have purchased the book, please, I beg you, leave us a review on Amazon. Well, assuming you enjoyed it. If you didn't enjoy it, you could just write us an Astigram and vent. That's cool too.
No, I usually say if you didn't like it, and I wrote
a book. But thanks everybody, and we'll see you next time.
Thanks everybody. Appreciate everybody showing up.
Oops. I gotta end the stream.